Incompatibility. The undesired change takes place in the physical, chemical, or therapeutic property of the medicament of a prescription are mixed together is termed as incompatibility. So, what is incompatibility? It is nothing but incompatibility occur as a result of mixing two or more antagonistic substances together. What happened? An undesirable product is formed, then which may affect the safety, efficacy, and appearance of the pharmaceutical preparation. That is not that is known as incompatibility. Okay. Then this incompatibility occur at any stage of dispensing. Then while handling a prescription containing combinations, many times problems associated with the therapeutic property, physical property, or chemical property of the drug. That means the interaction of drug with another drug, or the interaction of drug with additives or excipients, may occur at any stage of the dispensing. Okay, these all comes under incompatibility. Then different types of incompatibility. First one is unintentional incompatibility and intentional incompatibility. We can see what is unintentional incompatibility. Unintentional means unknowingly the prescriber prescribe incompatible drugs together. Okay, that is called unintentional incompatibility. That means when the prescriber prescribes the drug without knowing that there is an incompatibility between the prescribed drugs. Okay, that is known as unintentional incompatibility. Then next is intentional incompatibility. Intentional means what? The prescriber wants that the prescription be dispensed as it is. Okay, that means when the prescriber knowingly prescribe the incompatible drugs together, that is known as intentional incompatibility. Then one more classification is there, that is tolerated incompatibility as well as adjusted incompatibility. What is tolerated? Interactions is minimized, but combination of the prescription is not altered. That means combination is not altered. In case of a formula, we don't change any ingredients of the formula, but somehow we reduce the interaction. Okay, what is that? In tolerated incompatibility, the chemical interaction can be minimized by changing the order of mixing or mixing the solution in dilute form, but no alteration is made in the formulation. Okay, or no alteration in the combination of drugs. That is known as tolerated incompatibility. Then the next one is adjusted incompatibility. What is that? Interaction is prevented by addition or substitution of constituents without affecting the medicinal activity of the preparation. Okay, in case of adjusted incompatibility, we made some adjustments. What type of adjustments? The chemical interaction can be prevented by addition or substitution of one of the reacting ingredient of the prescription with another ingredient of equal therapeutic value. Okay, this is the adjustment we made. Okay, for example, in case of caffeine citrate can be substituted with a caffeine in sodium salicylate and caffeine citrate mixture. So the preparation is sodium salicylate and caffeine citrate mixture. In this preparation, caffeine is a therapeutically active ingredient. But if we add caffeine into the formulation, it may cause some incompatibility. So what we do, we change caffeine or we replace caffeine with the caffeine citrate. So that means instead of caffeine, we add caffeine citrate into the formulation. Okay. So there is no therapeutic change because caffeine and caffeine citrates have same therapeutic activity, but instead of caffeine we use caffeine citrate. Okay, so this is the adjustment we made. So adjusted incompatibility means A chemical interaction can be prevented by addition or substitution of one of the reacting ingredients. Okay, but this is the common classification of incompatibility. Which all are they? Unintentional incompatibility, intentional incompatibility, tolerated incompatibility, and adjusted incompatibility. The next is different types of incompatibility. Incompatibilities are of different types, which can be broadly classified into three types. First one is therapeutic incompatibility, then physical incompatibility, and chemical incompatibility. So, what is chemical incompatibility? So, in this, we discuss only about chemical incompatibility. So, we can see what is chemical incompatibility. What is that? Chemical change takes place due to the interaction of prescribed substance leading to the formation of a harmful or a dangerous product. Okay, that is known as chemical incompatibility. That means chemical incompatibility may be result as a result of chemical interaction between the ingredients of a prescription, and a toxic or an inactive product may be formed, and this is known as chemical incompatibility. And why or what reason these type of chemical incompatibility occur? Okay, that is, this chemical incompatibility is occur due to various reasons such as oxidation, reduction, hydrolysis, or combination of any of the two, or combination of both. Okay, but these are the reasons of chemical incompatibility. Chemical incompatibilities usually occur due to oxidation, reduction, acid-base hydrolysis, or combination reactions that we know. These reactions may be identified by precipitate formation or effervescence, decomposition, color change, or by explosion. By all these things, we can identify that a chemical incompatibility occurred. The prescription having chemical incompatibility should be dispensed only after its correction by the prescriber. Okay. So once chemical incompatibility occur, the prescription should be referred back to the prescriber for necessary corrections. Don't dispense the incompatible prescription as such. Yes, we know that this chemical incompatibility occur due to chemical interactions between the ingredients such as oxidation, reduction, or acid-base hydrolysis, etc. Okay, so the reacting ingredients. We know that all drugs are chemical substances. When we mix different chemical substances together, definitely chemical interactions may occur. Okay, if the interactions are undesirable, we call it as incompatibility. In case of chemical incompatibility, if the reacting ingredients are weak acid, you just consider if it is a weak acid or a weak base, it undergo a weak chemical reaction. Okay, if the reaction is weak, automatically the product also is very weak, and the reaction also is very weak. So in case of weak precipitate, we call it as diffusible precipitate. Okay, if the formed precipitate is diffusible and its quantity is very small, how we can overcome? We use method A. Okay, what I said, if the reacting ingredients are very weak acid or weak base, it undergo slow reaction, slow chemical reaction, and it form, you just think, formed compound is a precipitate, and if the formed precipitate is diffusible in nature and its quantity is very less, it can be overcome by following method A. So what is method A? Yes, here divide the vehicle into two equal portions. Then dissolve one of the reacting substance in one of the portion and dissolve and the other reacting ingredient in the other portion and dissolve. Okay, and mix these two portions by slowly adding one portion to the other with rapid stirring. Okay, so that is method A. What is that? Add one of the reacting first we divide the vehicle into two equal halves, then one reacting substance is add into the first half of vehicle and dissolve. Second reacting ingredient is dissolved in second half of the vehicle and dissolve. Then mix these two solutions together. Okay, so that is method A, and by this method A we can prevent uh, in method B. What is method B? If the reacting ingredients are very strong and a strong chemical reaction will occur, what happened? A strong product is formed. Okay, a strong precipitate is formed, and that precipitate is very difficult to diffuse. Okay, in solution. At that time, we call it as indiffusible precipitate. So, what is that? The reaction between strong solutions which proceeded at a faster rate and the precipitate formed are very thick and large quantity and do not diffuse readily. Okay, so that type of precipitates are known as indiffusible precipitate and its quantity is high or large. What we do, we can overcome this chemical incompatibility by following method B. So what is method B? Method B is nothing but which is somewhat similar to method A, that is divide the vehicle into two equal portions and add one of the reacting ingredient in one portion and the other reacting ingredient in other portion but in a different way. So weigh that is weigh suitable quantity of compound sugarcane powder or sugarcane mucilage. Its concentration is 2%. That means 2 gram per 100 ml of compound sugarcane powder we can use. So in this method B, we use an extra ingredient, that is compound sugarcane powder, into the formula. Okay, so what we do is we take a mortar and add compound sugarcane powder of 2% or compound sugarcane mucilage, transfer to a mortar and add some quantity of vehicle and triturate well to form a smooth mucilage. Then into that mucilage we can add the other reacting ingredient, and by trituration we can make it into a smooth solution or smooth mucilage. Then mix the first reacting ingredient which is dissolved in half part of vehicle. That portion we can add into the second part which is present in the mortar. Okay, and mix by thorough trituration. Then we can add all the rest adjuvants or ingredients into it. Mix well to form a uniform solution. Okay, and make up the oleum with the vehicle. Okay, but that is method B. Then after the preparation of method A as well as method B, a secondary label, that means shake well before use or shake the bottle before use, should be fixed on the container whenever method A or method B is used for dispensing the preparation. Okay, that's all about method A and method B. So by using this method A and method B, we can overcome the chemical incompatibility. But the prescription having, first we identify the prescription is having a chemical incompatibility, it should be dispensed only after its correction by the prescriber. Okay, that's all about method A and method B. Now we can see different types of chemical incompatibility. In that first one is alkaloidal incompatibility. So many examples of alkaloidal incompatibilities are there. We can discuss one by one, and the type of incompatibility and how will be overcome the incompatibility, that we can discuss in detail. So in that first one is alkaloidal incompatibility. So many examples I told you. The first one is alkaloidal salts with a alkaline substance. Yes, this is a type of chemical incompatibility, and here the two reacting ingredients are, one is, from the heading itself we know that one is alkaloidal salt and the other reacting ingredient is an alkaline substance. Okay, in a prescription or in a formulation, these two ingredients are combined together. That means alkaloidal salt and alkaline substance is present in a particular formulation. It undergo chemical incompatibility. Okay, or if in case of a combined administration of different drugs together, one of the drug is an alkaloidal salt and other drug is an alkaline substance, definitely a chemical interaction will occur. Okay, so we can see one example. First one is alkaloid salt with alkaline substance, and we know that alkaloids are weak bases, that we already know, and the alkaloids are almost insoluble in water. Okay, but alkaloidal salt, that means it is a salt. The salts are soluble in water. Okay, alkaloidal salts are soluble in water, but alkaloids are insoluble in water. um, Examples of alkaline substances such as strong solution of ammonium acetate, aromatic spirit of ammonia, solution of ammonia, ammonium bicarbonate, sodium bicarbonate, etc. are alkaline substances. If we dispensed or if a doctor prescribed an alkaloidal salt along with an alkaline substance, these two undergo chemical reaction, and what happened? A free alkaloid get precipitated. Okay, the free alkaloid is a product and it is precipitated in the formulation. However, they are not always precipitated because all alkaloids are slightly soluble in water. We can see one example. So in this prescription, this RX contain strychnine hydrochloride solution 6 ml, aromatic spirit of ammonia 4 ml, and water up to 120 ml. Okay, so this is a prescription. In this prescription, strychnine hydrochloride is an alkaloidal salt. Yes, it's a hydrochloride. It's a salt. But aromatic spirit of ammonia is an alkaline substance. Okay, but this prescription contains one alkaloidal salt and the alkaline substance. Strychnine hydrochloride is an alkaloidal salt and aromatic spirit of ammonia is an alkaline substance. Okay, what happened? When they react together, the strychnine get precipitated. That means free alkaloids such as strychnine get precipitated. Okay. And the quantity of strychnine hydrochloride prescribed in the prescription is much more than its solubility in water. Its solubility is 1 in 7,000. Its quantity is somewhat high. And the aromatic spirit of ammonia contain negligible amount of alcohol which cannot dissolve the strychnine. Okay, so the free alkaloid such as strychnine get precipitated, which is precipitated as in the form of diffusible precipitate. Okay, if the precipitate is diffusible and the quantity is less, it can be overcome by method A of precipitate yielding interactions. Okay, so what is method A? Method A is nothing but divide the vehicle into two equal portions and add one of the reacting ingredient in first portion of the vehicle and dissolve in the same way second reacting ingredient is dissolved in second portion of the vehicle. Now the no free first and second ingredients. Okay, The first ingredient is in the dissolved form. In the same way, second ingredient is also in the dissolved form. Okay, so there is no free alkaloidal salt as well as alkaline substance. It is in solution form. Then we mix these two portions by slowly adding one portion to the other portion with the rapid stirring. Okay, by this method A, we can overcome the precipitate formation. Okay, interaction of alkaloidal salt with soluble iodide is a type of alkaloidal incompatibility which comes under chemical incompatibility. Okay, in this reaction, one of the reacting ingredient is an alkaloidal salt and the other reacting ingredient is a soluble iodide. In case of a cough mixture, potassium iodide is generally prescribed as an expectorant along with tincture epicacuana. Okay, in this prescription, tincture epicacuana contain an alkaloidal substance such as emitin. Okay, the quantity of emitin present is usually so low that it cannot react with potassium iodide to get precipitated as hydroiodides. Example, tincture epicacuana contain emitin is commonly used along with the potassium iodide in the treatment of cough as an expectorant. What happened? The tincture react with the potassium iodide, and we know that tincture epicacuana contain emitin as an alkaloidal substance. So this emitin, tincture epicacuana react with the other ingredients such as potassium iodide. Then what happened? An insoluble hydroiodides get precipitated. Clear? Tincture epicacuana contain emitin as an alkaloidal substance or alkaloidal salt which interact with the other ingredient, that is potassium iodide in case of cough mixture, and these two ingredients react together and to produce hydroiodides, okay, which is insoluble in nature, and it formed as a diffusible precipitate. Okay, so then strychnine is used as a bitter stomachic which is used to increase the appetite. It interacts with soluble iodides to precipitate insoluble diffusible hydroiodides. Okay, so the formed precipitate is insoluble and which is diffusible in nature. So this problem can be overcome by method A. What is method A? Method A is nothing but add or divide the vehicle into two equal halves, add one of the reacting ingredient in one half and dissolve it completely, and the second reacting ingredient into the second half, again dissolve it completely and mix these two solutions together with the rapid stirring. Okay, so here dissolve vehicle into two equal half, add what? Tincture epicacuana in one part of vehicle and dissolve it completely. In the same way, potassium iodide is dissolved in second part of the vehicle, dissolve it completely and mix these two ingredients together. Okay, so by following method A, there is no free potassium iodide and no free tincture epicacuana which is in solution form. Okay, so upon mixing there is no free ingredient, so it does not interact together and form precipitate. Okay, so we can dispense this prescription as such by following method A of precipitate yielding interactions. If a prescription contains an alkaloidal salt along with the tannins, it undergo a chemical reaction. Okay, so this is a type of chemical incompatibility. What is that? An alkaloidal salt when combined with a drug containing tannins. The alkaloids form tannides, which are separated as diffusible precipitate. What I said, if a prescription contains an alkaloidal salt along with tannin, these two ingredients undergo chemical reaction and corresponding tannins get precipitated as diffusible precipitate. Okay, so if the formed precipitate is diffusible in nature, how we can overcome the problem? We can overcome it by following method A. What is method A? Method A is nothing but divide vehicle into two equal halves, add one of the reacting ingredient, that means alkaloidal salt, in one half of the vehicle and dissolve it completely. Then another reacting ingredient such as tannins in another half of ingredient and dissolve it completely and mix these two solutions together by rapid stirring. Okay, so by following method A, we can overcome this chemical incompatibility. Next incompatibility is alkaloidal salt with soluble iodide and bromide. This is also a type of alkaloidal incompatibility which comes under the chemical incompatibility. Here, what happened? An alkaloid such as strychnine, morphine, codeine, etc. interact with the soluble iodide or soluble bromide. Okay, if these alkaloids are interact with the soluble iodide, what happened? Insoluble hydroiodides may get precipitated. A second thing is, if the alkaloidal salts are interact with the bromide, what happened? Corresponding hydrobromides are precipitated. Okay, and these formed precipitates are are insoluble and diffusible, so it can be overcome by method A. For example, Rx, potassium iodide 1.5 gram, tincture of stramonium 8.5 ml, and chloroform water to make 100 ml. Okay, so in this prescription, tincture stramonium contain solanaceous alkaloid. Okay, so in a prescription, tincture stramonium interact with the potassium iodide. Okay, and we know that the tincture stramonium contains solanaceous alkaloid. They interact together. What happens? Hydroiodides get precipitated. Okay, and it is diffusible in nature and it can be overcome by method A. So how we can follow method A here? Here the vehicle is chloroform 100 ml. So we can divide the chloroform into 50 ml and 50 ml. Then add one of the reacting ingredient in one half. That means first we dissolve potassium iodide in 50 ml of chloroform water, dissolve it. Then tincture of stramonium dissolved in another 50 ml of chloroform water. Then mix these two solutions 50 ml 50 ml together to produce 100 ml. So by following this method A, we can overcome this chemical incompatibility, that is alkaloidal salt interact with the soluble iodide and bromide. Alkaloidal salt with salicylate is a type of chemical incompatibility. When quinine compounds are combined with salicylate, what happens? It forms indiffusible precipitates of quinine salicylate. Okay, the precipitate is indiffusible, so it can be overcome by method B. We can see one example. Rx, a prescription containing different ingredients. Rx, quinine hydrochloride 0.12 gram, sodium salicylate 4 gram, and water up to 100 ml. So in this prescription, we need to prepare a mixture. Okay, so that is the direction. Then in this prescription, quinine hydrochloride on a reaction with the sodium salicylate. One is alkaloidal salt and the other one is a salicylate. Okay, quinine hydrochloride is an alkaloidal salt and salicylate example is sodium salicylate. When these two ingredients are present in a prescription, what happen? These two things are interact together and form quinine salicylate. Okay, which get precipitated as in the form of indiffusible precipitate. Okay, so the formed precipitate is indiffusible in nature. What happened? It can be overcome by following method B. So what is method B? Method B is nothing but we divide the vehicle into two halves, add one of the reacting ingredient into the first half and dissolve it, then take a mortar and add what compound tragacan powder into mortar, add some amount of vehicle, triturate well to form a mucilage. To that mucilage we can add second reacting substance. Okay, and mix together. So there is no free second reacting ingredient. Now it is inside the mucilage. Okay, but there is no free reacting ingredient. Okay, so then we can mix the first solution which contain first reacting ingredient into the mortar which contains second reacting ingredient, then mix by thorough trituration. Okay, then if any other ingredients are there, we can add into it. If in this prescription no other extra excipients are there, then we can add a full amount of mixer A into the mortar, then add remaining part of the vehicle, triturate well to form a homogeneous solution, then make up the volume with the remaining part of vehicle, transfer to container, label and dispense. And we know that in this prescription the formed precipitate is indiffusible. Okay, so what we need to fix a label, that is shake the bottle before use, must be fixed over the bottle. Okay, thank you. This is soluble salicylate incompatibility. This is also a type of chemical incompatibility. Here, soluble salicylate interact with the ferric salt. That means in a formulation, if one of the ingredient is a soluble salicylate and the other ingredient is a ferric salt, definitely it may undergo certain chemical reactions. Okay, then the ferric salt react with the soluble sodium salicylate to liberate indiffusible precipitates of ferric salicylate. Example, ferric chloride solution 2 ml, sodium salicylate 3 gram and water up to 30 ml, and need to make a mixture. Okay, so in this prescription, soluble salicylate is sodium salicylate and ferric salt is ferric chloride solution. Okay, so the ferric chloride react with the sodium salicylate to form ferric salicylate. Okay, which get separated as what type of precipitate? It is separated as indiffusible precipitate. Okay, if the precipitate is indiffusible in nature, we can overcome this problem by following method B for precipitate yielding interaction. Okay, so what is method B? We divide the vehicle into two equal halves, add one of the reacting ingredient in first half and the second reacting ingredient is mixed with the compound tragacan powder or compound tragacan mucilage. Okay, then add the first reacting ingredient into the second reacting ingredient containing compound tragacan mucilage and triturate, mix by trituration. Okay, then add all the rest ingredients and make up the solution. Okay, or make up the oleum by adding more amount of vehicle. Okay, but that is one method. And in the same way, and one more alternative is here. In the presence of sodium bicarbonate, the precipitate of ferric salicylate remains soluble. Okay, that means if we add sodium bicarbonate into the formula, what happened? The formed indiffusible precipitate of ferric salicylate becomes soluble. Okay, and we will get a clear solution. Okay, so in that way also we can dispense the prescription. So but this is one method. Here we can use or we can opt method B of precipitate yielding interaction, or in the other way we can incorporate sodium bicarbonate into the formulation. Okay, so here the prescription is ferric chloride solution 2 ml, sodium salicylate is 3 gram, sodium bicarbonate is 8 gram, and water up to 90 ml. Here the reaction will occur, that means interaction with the ferric chloride and sodium salicylate will occur, and an indiffusible precipitate is formed. But if we add sodium bicarbonate into the formula, or if we include sodium bicarbonate into the formula, what happened? The formed precipitate becomes soluble. Okay, so the procedure is dissolve sodium salicylate and sodium bicarbonate in 70 ml of water, add ferric chloride solution into it, then presence of sodium bicarbonate effervescence may occur. When effervescence has ceased, filter the solution through cotton wool and pass sufficient water through the filtrate to produce 90 ml. Okay, so by this way also we can dispense this prescription. The first method is we can follow method B, or the second method is instead of method B we can add one ingredient into the formulation. Okay, this is a type of adjusted incompatibility. So we add sodium bicarbonate into the formulation. Okay, and we can dispense this as a clear solution. Interaction of soluble salicylates and benzoate with acids. This interaction is a type of incompatibility which comes under chemical incompatibility. So what is that? This is the interaction of acids with the salicylates as well as benzoates. That means most of the acids and acid syrup, for example acid syrup which contains syrup of lemon, which decomposes sodium salicylate as well as sodium benzoate. That means a prescription containing sodium salicylate or sodium benzoate along with acid. These acids undergo reaction with the sodium salicylate as well as sodium benzoate, and it undergo decomposition to form precipitates. Okay, precipitates of what? Precipitates of salicylic acid as well as benzoic acid respectively. And what type of precipitate it is formed? Yeah, the precipitates formed are indiffusible in nature. Okay, so indiffusible means it is very difficult to diffuse. Okay, so this method can be overcome, or this problem can be overcome by following method B for precipitating yielding interactions. Okay, yeah, for example, sodium salicylate 3 gram, syrup of lemon 15 ml, water up to 60 ml, and make a mixture. Okay, so in this prescription we know that one ingredient is sodium salicylate and the other ingredient is syrup of lemon. Okay, syrup of lemon contain citric acid. Lemon contains citric acid, that we know. So the acid, that means citric acid, present in lemon syrup, it react with the sodium salicylate. What happened? Salicylic acid is separated as indiffusible precipitate. Okay, so this prescription can be dispensed in two ways. First method is we can follow method B for precipitate yielding interactions. Okay, so that is one option, and the other option is replace syrup of lemon with a simple syrup here, or tincture of lemon, because syrup of lemon is prescribed as a flavoring agent only. Okay, we need flavor only, so syrup of lemon and its replacement with a simple syrup or tincture of lemon will not affect the therapeutic value of the mixture. Okay, so this incompatibility can be overcome by two methods in this prescription. Either we can follow method B, or we can replace syrup of lemon with a simple syrup or tincture of lemon as a flavoring agent. Okay, and we can dispense the prescription as such. Another example is sodium salicylate 2 gram, quinine sulfate 0.5 gram, dilute sulfuric acid 2 ml, and water up to 100 ml. Then make a mixture. Here our ingredients are here. Sodium salicylate as well as dilute sulfuric acid is here. Okay, one is soluble salicylate and the other one is an acid. Okay, here quinine sulfate is not freely soluble in water. Okay, and in this prescription, why we add dilute sulfuric acid? Dilute sulfuric acid has been included by the prescriber to dissolve quinine sulfate. Okay, but the problem is this acid react with the other ingredients such as sodium salicylate. Okay, if the prescriber overlooked the fact that the acid would decompose the sodium salicylate, okay, and prevent the formation of a clear mixture. Why? Because this acid, dilute sulfuric acid, interact with the sodium salicylate. Actually, sodium salicylate is dissolved in water, but in the presence of dilute sulfuric acid, which undergo decomposition reaction, and salicylic acid get precipitated as indiffusible precipitate. Okay, so the solution will not be clear one. Okay, it contains certain precipitates of salicylic acid. Okay, so this can be overcome by either we can follow method B for precipitate yielding interaction, or here the problem is interaction of sodium salicylate with a dilute sulfuric acid. Sodium salicylate is having therapeutic activity, quinine sulfate is also having therapeutic activity, but dilute sulfuric acid does not have any therapeutic activity in this prescription. It is included for what purpose? It is just included to dissolve quinine sulfate in water. Okay, so in order to prepare a clear mixture, we can omit dilute sulfuric acid and can dispense. So the two methods are either we can follow method B, or we can remove dilute sulfuric acid in this prescription and we can dispense the solution as a clear mixture. Now we can discuss about soluble iodide incompatibility. Iodides undergo oxidation, forming free iodine, which is an undesirable product. In that, first one is oxidation of iodide with a ferric salt. When ferric salts reacts with soluble iodide, it gets converted into ferrous salt. What is that? When ferric salt react with the soluble iodides, it get converted into ferrous salt. There is no satisfactory method to adjust this incompatibility. That means Fe3 plus 2I gives Fe2 plus I2. So to prevent this incompatibility, the prescriber may substitute ferric salt with iron and ammonium citrate, which does not yield ferric ions. For example, prepare and dispense 90 ml of the following mixture: Rx ferric chloride solution 1.5 ml, potassium iodide 3 gram, potassium citrate 6 gram, and water up to 90 ml. Make a mixture. Direction: 1 tablespoonful to be taken 2 times a day. So here ferric chloride solution react with potassium iodide, and we know that it liberates free iodine. The reaction is 2FeCl3 plus 2Ki gives 2FeCl2 plus 2KCl plus I2. So in this reaction, last iodine gas is formed, or I2 is formed. To prevent the liberation of iodine in this mixture, the ferric chloride is converted into a colloidal organic compound before the addition of potassium iodide. So how we can prepare it? First, dissolve potassium citrate in 3 by 4 quantity of water. Add ferric chloride solution and mix together, which form a colloidal organic compound. Then add potassium iodide into it. So, ferric chloride is in contact with the potassium citrate. There is no free ferric chloride is to react with the potassium iodide. Okay, add more water to adjust the final volume. Okay, so by this way we can overcome the incompatibility. That means this incompatibility can be overcome by adding a new compound, that is potassium citrate, we can add into the formulation. And this does not have any therapeutic activity. Why we add potassium citrate into it? To prevent the interaction between ferric chloride solution and potassium iodide. Okay, so these two are the reacting ingredients. So the procedure is, first we dissolve potassium, first we take a new compound, that is potassium citrate, about 3 by 4 of water, dissolve, then add ferric chloride solution into it, make it a uniform mixture, then add potassium iodide into it. Then add more amount of water, make up the volume and dispense. And here the color of the mixture will be green due to the formation of a new compound by the reaction between ferric chloride and potassium citrate. And the reaction is as follows. Now we can discuss about oxidation of iodides with quinine sulfate. This is a type of iodide incompatibility, and which is a chemical incompatibility. Here the interacting reagents are, or ingredients are, iodides and quinine sulfate. Yes, we can see what is that. Quinine sulfate is not freely soluble in water. It is made soluble in the presence of dilute sulfuric acid. Okay, this dilute sulfuric acid interact with the potassium iodide, and which may cause the liberation of hydroiodic acid from potassium iodide. This hydroiodic acid is partially oxidized by the remaining sulfuric acid, and which will yield a new compound, that is iodine. Okay, the iodine, the newly formed iodine, hydroiodic acid, and active ingredient quinine sulfate then combine to form a new compound called herapatite or iodosulfide of quinine. So what I said, in the prescription quinine sulfate is there. So and the vehicle is water. The problem is quinine sulfate is not freely soluble in water. So to make it soluble, we add dilute sulfuric acid into it. This dilute sulfuric acid interact with the other ingredient, which is potassium iodide, which is present in the formula. Okay, and which produce or which liberate hydroiodic acid. And next step is, this hydroiodic acid is partially oxidized by the sulfuric acid, which produce iodine. So in this formula contains some ingredient, but because of this chemical interaction, two new compounds are present inside the container, that is hydroiodic acid and iodine. Okay, so this formed iodine, hydroiodic acid, and main ingredient quinine sulfate are combined together to form a new compound. That compound is known as herapatite or iodosulfide of quinine, and its chemical formula is C20H22 or 4N2 3H2SO4 2Hi 2I2 6H2O. So this is a chemical formula of herapatite or iodosulfide of quinine. This in how we can overcome this incompatibility. Yes, this incompatibility can be prevented by some methods. First one is patient should be supplied with a mixer only for 3 days. That means this reaction is a slow reaction. It takes place only after 3 days. So what we can do, patient should be supplied this mixer only for 3 days. Okay, then second case is in case of patient require a mixture more than 3 days. So both the solutions are prepared in half the volume of water and supplied in separate bottle with proper direction. So what all ingredients we need to separate? Here the first two reacting ingredients are sulfuric acid as well as potassium iodide. So we need to separate sulfuric acid in one bottle and potassium iodide in another bottle. Okay, and dispense with proper direction. You look at the example. This example contain RX quinine sulfate 1.5 gram, dilute sulfuric acid 4 ml, potassium iodide 8 gram, and water to make 100 ml. So here quinine sulfate is a therapeutically active ingredient. Potassium iodide is also having therapeutic activity, and water is the vehicle here. Okay, but the problem is quinine sulfate is not freely soluble in the vehicle. So to make it soluble, we add dilute sulfuric acid into the formulation, and it does not have any therapeutic activity here. Its role is to solubilize quinine sulfate in the medium. But what happened? This dilute sulfuric acid interact with the next ingredient, that is potassium iodide, and which cause the liberation of hydroiodic acid. Okay, then this hydroiodic acid again interact with the dilute sulfuric acid to liberate free iodine. Okay, and this iodine, hydroiodic acid, and quinine sulfate combine to form herapatite. Okay, and this mixture formed is quite clear at first, but after 3 days it may get deposit bronze or olive green scales. Okay, this may cause confusion in the mind of patient before, because at the first day the solution is very clear, but after 3 days its color changes, and it may contain olive green scales or flake like substance which is present inside the bottle. Definitely it may cause confusion in the mind of patient. Okay, so how we can overcome this problem? It can be overcome by, first one, dispense this prescription only for 3 days, or otherwise separate the reactive ingredients into separate bottles and dispense the patient with proper directions. Okay, so here dilute the procedure is dilute the sulfuric acid with 100 ml of water and dissolve quinine sulfate into it, that is one bottle, kept in one bottle. Then potassium iodide is dissolved in remaining quantity of the water and mixed and dispensed in another bottle, and ask the patient to mix these two bottles together when the time of administration. Okay, so this is Herapath reaction and how we can overcome this Herapath formation. Now we are discussing about the chemical incompatibilities causing evolution of carbon dioxide gas. When carbonates or bicarbonates are dispensed in the presence of an acid or any type of acidic drug in a particular formulation, they react together with the presence of or with the evolution of carbon dioxide gas. What I said, when carbonates or bicarbonates are dispensed along with acid or any type of acidic drug, it undergo chemical reaction and may cause the production of carbon dioxide gas. The formation of carbon dioxide gas is the incompatibility, and it is a type of chemical incompatibility. If the reaction is not allowed to complete before transferring the formulation or mixture into a dispensing bottle, and if we cork, there is a chance of explosion with the bursting of bottle. What I said, if the reaction, definitely the reaction will occur. Okay, so we need to allow the reaction to complete before transferring it into the bottle. Otherwise, what happened? If the reaction is not allowed to complete before transferring the mixture into a dispensing bottle and we cork, there is a chance of explosion because after a period of time chemical reaction will takes place and carbon dioxide gas is formed, which filled inside the container and which may cause the bursting of bottle. So in order to prevent the explosion, what we do? So to prevent the explosion, the reaction must be completed. We allow to complete the reaction before transferring it into the container. So to speed up the reaction, what all things we can do? To speed up the reaction, we can mix the ingredients in an open vessel, that is one thing, and allow the reaction to complete until effervescence ceases. And another method is, instead of cold water, in case of vehicle, instead of cold water we can use hot water, okay, which hasten the reaction or which speed up the reaction. Okay, but this is the two methods. So to prevent this explosion, the reaction must be initially carried out in an open vessel and we wait for the completion of effervescence before transferring the mixture into the dispensing bottle. And other method is, it must be carried out in presence of hot water and this heat will accelerate the rate of reaction. So by this method we can prevent the chemical carbon dioxide evolving chemical incompatibility. Reaction between borax, sodium bicarbonate and glycerin is a type of chemical incompatibility which causes the liberation of carbon dioxide. When borax and glycerin are dispensed together, they react to form sodium metaborate and boric acid. The reaction is as follows. Here Na2B2O4 is sodium metaborate and H3BO3 is boric acid. The boric acid thus formed again react with the glycerin to form a monoboric acid known as glyceryl boric acid. The acid reacts with the sodium bicarbonate, liberates carbon dioxide gas as in the form of effervescence. Clear? So this is the carbon dioxide evolving reaction. The ingredient should be mixed in an open vessel and mixing should be continued until the effervescence ceases. Okay, the second reaction is glycerin react with the boric acid to form glyceryl boric acid. Yeah, you look at the example. Sodium bicarbonate 1 gram, borax 1 gram, phenol 0.5 gram, glycerin 20 ml, water up to 90 ml. Make a spray solution. Here The above mixture is an excellent example of a decarboxylation reaction. That is, it results in the evolution of carbon dioxide gas due to the reaction between borax, sodium bicarbonate, and glycerin. Hence, these substances should be mixed in an open vessel and it produces effervescence. That means evolution of carbon dioxide gas. The effervescence should be allowed to cease completely before transferring the mixture to the bottle, after which the phenol should be added and shake well, transferred to container, label and dispense. Clear? Here, when sodium bicarbonate, borax and glycerin are mixed together in the presence of water, a reaction takes place with the evolution of carbon dioxide gas, okay, as in the form of effervescence. If the mixture is dispensed as such, there is a chance of bursting of bottle. Therefore, mix these ingredients in an open vessel until evolution of carbon dioxide gases ceases. Add phenol and transfer the mixture to bottle. So this is an example of carbon dioxide evolving reaction is a type of chemical incompatibility. Now we are discussing with the reaction of a sodium bicarbonate with a soluble calcium or magnesium salt. This is also a type of carbon dioxide evolving reaction because it contains sodium bicarbonate and it is a type of chemical incompatibility. Here, when sodium bicarbonate is combined with the soluble calcium or soluble magnesium salt, it undergoes decomposition reaction and there is a formation of insoluble carbonates and carbon dioxide gas. Okay, but this is the formation of carbonates as well as carbon dioxide gas is incompatibility. The reaction is here it is calcium sulfate react with the sodium bicarbonate. Calcium bicarbonate plus sodium sulfate is formed. This is the first interaction. Then this formed calcium bicarbonate again undergo decomposition to form calcium carbonate, calcium hydroxide, carbon dioxide and water. In this carbon dioxide is formation of carbon dioxide is a type of chemical incompatibility. Yes, we know that this is a double decomposition reaction and it is proceeds slowly at room temperature. But what if we use hot water, which will accelerate the rate of reaction? To avoid the possibility of explosion, the mixture should be transferred into the dispensing bottle only after the effervescence ceases. The carbonates are formed is insoluble in water and separated out as diffusible precipitate. So the formed precipitate is diffusible in nature, so it can be overcome by method A for precipitate yielding interactions. Now we can discuss about different types of miscellaneous chemical incompatibility. First one is interaction between barbiturates and ammonium bromide. Then the second one is interaction between potassium chlorate and an oxidizable substance. Then the next miscellaneous chemical incompatibility is incompatibility affecting stability of dyes and incompatibility of glycyrrhiza extract with acidic drugs. These are some examples of miscellaneous chemical incompatibility. Here we can discuss about the interaction between potassium chlorate and an oxidizable substance. Potassium chlorate should not be dispensed with any dry or oxidizable substance. such as charcoal, sulfur, sugar, and organic compounds. As any heating or trituration during the dispensing may result in explosion. It may cause violent explosion. So how this incompatibility occur? Potassium chloride is a highly reducing substance. The highly reducing substance is dispensed along with the highly oxidizing substance. Definitely a strong reaction will occur. For example, highly reducing substance such as potassium chloride is dispensed along with the highly oxidizing substances such as charcoal, sulfur, sugar, or any organic compound as any heating or trituration during the dispensing which may cause violent explosion. If we need to dispense, what to do? If essential ingredients should be separately triturated in a clean and dry mortar without any friction and can be dispensed separately. Look at this example. Here, potassium chloride 0.3 gram, tannic acid 0.15 gram, and sucrose 0.15 gram. Here, what is the problem? Here, highly reducing substance such as potassium chloride as well as highly oxidizing substance such as tannic acid is present here. If we mix it thoroughly, what happens? These two ingredients are highly reacting substances, so which undergo violent explosion. So how we can overcome this problem? The ingredients should be weighed and powdered separately with minimum amount of rubbing and friction. And these ingredients can either be mixed with a spatula on a sheet of paper in the ascending order of their weight. And that is one method, or the other method is we can dispense the reactive ingredients individually with proper directions. So in this prescription, which all are the reactive ingredients? Potassium chloride as well as tannic acid is the reactive ingredients. Okay, so we need to separate these two ingredients and it can be dispensed separately along with proper direction. That means during the time of administration, take one packet from one container and the other packet from the other container and can be combined together by spatulation and can consume. Okay, so by this way we can dispense this reactive ingredients together. The next miscellaneous chemical incompatibility is color stability of dyes. The color of the most of the dyes used in pharmaceutical formulations are influenced by their ionization, which depends upon the pH of the solution. For example, the phenolphthalein dye is colorless in acidic solution, but it is red in color in alkaline solution. Another example is reducing agents usually cause fading of color. Another point is anionic drug dyes are most stable at acidic pH. Example, amaranth. And basic dyes are often very sensitive to alkalis. For example, methylene blue. It may cause precipitation or may dye is affected by the oxidizing agent. This is a type of chemical incompatibility which is occurred due to the presence of liquid extract of licorice. Yes, we can see what is that. Licorice liquid extract is an aqueous alcoholic extract. It is manufactured by process where the extraction of licorice is performed with the purified water as well as ethanol. That means by using purified water and ethanol, we extract licorice. that is called liquid extract of licorice. Then licorice also sometimes spelled as licorice is a sweetening substance that is used in relieving inflammation or relieving irritation of the mouth. This is the therapeutic activity of liquid extract of licorice. Then licorice liquid extract is widely used in pharmaceutical industry and in the manufacturing of herbal medicine. It's as a flavoring agent, and it is also used in making soft drinks. Yes, we said already said that liquid extract is used as a flavoring agent. The flavoring property is due to glycyrrhizin, which is a mixture of potassium and calcium salt of glycyrrhizinic acid. Then this acid decomposes glycyrrhizin into glycyrrhizinic acid, which is insoluble in water and get precipitated. The precipitate clouds and forms a sticky blank sediment which is difficult to diffuse. The insoluble substances are not possessing flavoring property and liquid extract is not used as flavoring agent in acidic mixture. If we identify this type of incompatibility due to the presence of flavoring agent and acidic drug, this prescription may be referred back to prescriber for change the flavoring agent. Another thing is the salts like calcium chloride and magnesium sulfate cause partial precipitation of glycerin. Okay, so the precipitate is as in the form of diffusible precipitate. So it can be overcome by method A for precipitate yielding interaction.